Hi there, this is Kit Merker here, and I'm excited to share with you some ideas about DevOps for IoT today. And this is a talk that's adapted from a keynote that I gave at our user conference, Swamp Up, that was in Napa in June. So I'm gonna get right into it. All right, so when I think about IoT, the fundamental question I like to start with is, why does my coffee pot need to be connected to the internet? And this, to me, kind of exemplifies the hype around IoT. You take a device that's already in your house and you make it smarter. You connect it to the internet and you make it smarter. You have a refrigerator, you make a smart refrigerator. You have a dishwasher and you make a smart dishwasher. And I think this is part of why IoT projects kind of get seen as very hyped. And in fact, the hype around IoT is reaching a peak. I think most people are expecting that IoT has reached a peak. This is the cycle of the hype cycle of all technologies. And what you see happen is, some technology triggers this rise. And if it follows this cycle, we should see IoT quickly go to the trough of disillusionment when it doesn't, deliver on the promise that's been hyped in IoT. And when you look at the future of what's been sort of predicted, there's predictions that there could be as many as 75 billion devices in the world, and over the next 5 to 7 years, and that's just a staggering number of devices. And the idea that these will all be connected together and connected to the internet to make the world a better place is kind of this really a daunting idea. But as somebody who's a hero of mine, in fact, my first crush says, more is not necessarily better. Better is better. And this tautology is actually kind of insightful in this case, because just because there are more devices and things in the world that have to be connected together doesn't necessarily mean that it will create a better experience for humanity and for our businesses and our lives, just because there's more devices. And we need to think about, how do we make devices and things actually better. So returning to the hype cycle, what I would like to propose is that the techniques that are already popular, becoming popular in the DevOps domain, and a lot of our customers benefit from, we can actually take the principles of DevOps that exist today for cloud applications, and we can apply them to IoT with the goal of cutting the hype and the expectations and moving us directly to a more productive way of thinking about and building thing-based projects. And if you think back to the early days of web development, when everybody needed to get a website and the hype of the internet, if you will, very quickly, all those websites that were thrown together and managed quickly became mission critical. And my expectation is the same thing will happen with IoT before long. And I would hate for us to go back to that same experience with web pages, where we had to go and patch servers and manage the updates and releases, and everything would crash. So now we have DevOps tools that keep us continuously pushing patches to production. I'd like to see the same thing happen for IoT projects proactively, so we're not retrofitting the update process to the system. And I think that's how we can actually achieve this idea of moving directly to productivity. But what I want to spend a little time on is a few ideas related to what does it take to update things. But before I get there, I have my obligatory Wikipedia definition page with full pronunciation in phonetic English and everything. The way I want to use IoT and the Internet of Things and things, I'll use them kind of interchangeably. And I'm trying not to use it as kind of this hype, big idea thing. I'm trying to use it as a term to be descriptive. The basic checklist for what makes the Internet of Things is that, first of all, it's composed of physical devices that interact with the environment. So either with sensors that look for things like changes in temperature or humidity or light or sound, or actuators that actually control the environment. They can be switches or controls that physically interact with the environment in some way. Second important thing is that they have to be running software. You can't have devices that are statically hard-coded or non-computing. They have to be running software in some way that can be updated. They should be, or have to be, directly or indirectly connected to the internet. And what we see with devices is and things is that it's actually much more common for them to be indirectly connected to the internet now, where they'll use a gateway or hub of some sort that provides them the connection to the outside world, and then internally we'll use some local protocol or wireless technology like Zigbee or Bluetooth to have a local connection. And so they pass through a hub or gateway. And finally, the Internet of Things is powered by cloud services and data intelligence. This is what really lets you take the computing power down to a small form factor. It lets you put it anywhere. If you didn't have the cloud services and the connectivity and the data, it would be difficult, if not impossible, to actually build a large-scale IoT project that actually did anything useful beyond local computation. So these are sort of the key ingredients of what makes IoT IoT, and we'll use that throughout. In fact, this is the Venn diagram of all the computing that you need to worry about for your business in the future. And if you're familiar with DevOps, and I hope that you are, and you are running cloud services, you're probably pretty comfortable with how to update cloud software. And this is where we see most of the action over the last few years in sophistication around DevOps and continuous updates is on the cloud. And the cloud is this kind of invisible fabric of computing and data and services that just is everywhere. But there is actually a little bit of thinginess to it because you have to care about where the data centers are located and the speed of light of network connections and other things that kind of create, and data jurisdictions as well, data sovereignty jurisdictions. It creates a sort of presence or thinginess to your cloud. And then on the other side, things you can think of as broadly all the physical ways that your company interacts with your customers and your users. This is everything else. This is all of the stuff in the world, and it could take on a lot of different forms. It could be a retail store or signage. It could be a shipping container or even a shipping boat. It could be a building. It could be an autonomous truck. There are lots of examples of things that are driving business today in manufacturing and other places. But when you have a lot of things, they actually kind of behave like a cloud as well. They have computing near what's now being called the edge, or even more strangely, fog computing. But this idea that you're bringing computing power to the data, to the device, to the thing, and giving it almost a cloud-like capability, even though it is a physical software device. But when you update things in the real world, it actually gets a little bit tricky. And I want to walk through this a little bit. So on this diagram, this chart, I've got two axes. Basically, first a look at the x-axis, which is the update priority. So on the one extreme, you have a situation where you need an update. Your software maybe is insecure or needs a patch of some sort to fix a critical bug, and you actually need to update the software. It's very important to take that update. And on the other extreme, you've got a situation where you don't want to take an update. Maybe you've got something mission critical going on. Maybe you're flying an airplane. You've got a heart monitor set up. There's some extreme risk to loss of life or injury. You want to make sure that you don't take any changes at this time to avoid risk. And in the middle, you've got sort of your daily run-of-the-mill types of updates. You've got new software versions for features and functionality, performance improvements, all the stuff that kind of makes up the day of a software developer. On the other axis, the y-axis, you've got the spectrum of how much you want the user to have a say in the updates. And so this spans from completely automated, where it might even be invisible to the user. They don't even know that they've got a new version. They're just delighted when they see that things aren't breaking or it runs faster, or maybe it's even more subtle than that, the preventative security fix. They don't even know. And on the other extreme, you have completely manual user updates, where the user has to install something themselves, download a patch, install it. Maybe they have to buy some new software or a new device in order to get the update. In the middle, you have some scenarios where you kind of inform the user they're getting an update. Maybe you ask them to schedule it. So there's some various degrees of user control that can be involved. And this is not a 2x2 matrix that's created equal. There's actually an optimal zone in the middle. And this zone is what creates a delightful experience and is where you have to keep your update system if you're building an IoT software. And at JFrog, we believe that software should be liquid. And so the up and to the right category for us is this idea of liquid software. Liquid software should just flow to your users. It's software where you need the update and you also want it completely automated, or it can be completely automated. And so we want you to push 90% of the time, push the software in a liquid way. And of course, to be able to do that, you need to have the proper infrastructure in place to test and to roll back and everything else required from a DevOps perspective. But in the physical world, the escape hatch of being able to update on my own terms becomes really, really important. You want to make sure that you don't always push software in a liquid fashion, but when the time is right and when there's risks or other things, you give the user an acceptable way to control the flow of updates. Now, outside of those safe zones, things happen as well. And so one example of this is, let's say you take you have a Heartbleed security vulnerability, or you've got maybe other things like the ransomware patches that were required recently that made the news. The problem here is that you basically have a very, very critical fix that requires manual intervention from users. And what that leads to is annoyance and procrastination. And the user ends up really in a bad state. So that type of update should be liquid. That's what we would suggest. And this makes it much better for IoT scenarios. On the other hand, on the other side, outside of the areas, what I call the ethical quandary, which is basically where, I'll give you an example of, you have a car, and the car is running a whole bunch of different software systems, and you're parked late at night in a dangerous parking garage, but the software needs to be updated right now. It's a forced update, and you can't drive the car while the software is being updated. Now, to me, this is just a terrible situation. And what it means is that the developers misunderstood the situation of the user. Either they should have looked at the severity of the fix and been able to push it. They misunderstood the severity of the fix. They should have been able to push it in a liquid way, or they were unaware of the context of the user when the update was happening, and therefore should have put the user to be more involved in the update itself. And so by being conscious of these trade-offs in the software system for IoT, we can use DevOps techniques and control those trade-offs appropriately. So any update system that you have that flows your updates to your IoT devices needs to let you control these updates, the trade-offs of these types of updates, and really decide between liquid and updates on your users' terms. So I want to walk through also re-architecting a system, a traditional system, into an IoT system, because I think this is also really instructive. So I've got this mythical building security system, and it's got three kind of major components. There's two systems involved here. So one part of it is a card reader, so security cards with a door, and the door can be open and closed based on local access management in some sort of database. And then off to the side, you've got Dave, the security guard, and Dave has a camera, and he can watch for people coming in, or he can fall asleep on the job and review the tape later. But this is a manual process, and it's a separate system from the building security. So you really have two building security systems. Well, if we take this system and we turn it into an Internet of Things style project, what we do is we keep the same things in play. We've got the card reader, the door, and the camera, but now we've connected them together with a Raspberry Pi based system that has software we can update. And so by changing this, we haven't changed the things, we've just changed how the things interact together. And what's nice about this is now we can actually update the software and make the system better. So as an example, let's say we wanted to trigger the camera to mark the footage whenever the door was opened or whenever the card reader was scanned. So we can push an update to it that adds this photo logging capability, and now the camera knows to write some data to the photo log. But we can actually take this even further, and let's say we push another update, and because we're connected to the internet, we can also use cloud services. So we could, for example, add facial recognition to it and add another layer of security. We could go even sort of beyond that and use cloud services that give you big data analysis. You could look at traffic patterns in your building, look for other kinds of patterns of suspicious behavior that you would really only be able to find through a machine learning model. And notice we did this without changing any of the things that were already in the building. The other interesting thing is if you're a cloud developer that's making the shift to your first IoT project, you can actually reuse a lot of the tools that you have today. Raspberry Pi is just a Linux computer, essentially. So if you're already familiar with Linux, you can do that. And because you're running Linux, you can actually run Docker containers. And there's some platforms emerging that are all Docker-based. And so if you want to write one piece of server-side logic, package it in a Docker container, and then be able to run it either in the cloud or on a device you can do that. And you can also have sort of one path to packaging for your IoT projects. And you can also use languages that you're familiar with. So whether that's, like I've got here Python, C and C++, and Ruby, but you can also use Node, and there's many other languages. A lot of the libraries are kind of written in Python, C and C++, Ruby, but there's anything you can run in a Docker container. Essentially, you can bring to a Raspberry Pi project, which is really kind of making it easy for people to get started. And the number of devices, sensors, etc., is exploding. There's single-purpose devices that do basically everything from a whole bunch of different manufacturers. They're getting easier and easier to use. One of the things that's interesting about this is that as you combine these devices to make an IoT project, there's not really standards or interop between these yet. And so what that indicates is that you're going to have to update your software. If you're running an IoT project, one of the critical things you'll need in order to keep that system stable and running well is a method for updating software. And I suggest that the sort of DevOps tools, if you can bring those forward, that will really help. So when you look at the different people involved in an IoT project, we have the customer who is probably buying into the hype, frankly. And this is somebody who maybe has an idea for an IoT project, and they want it to just work, and they want it to be cool, and they aren't necessarily going to be thinking about, well, how am I going to maintain it and how am I going to keep it up to date? They are going to be worried about if your drone falls out of the sky, if you will. They're going to be worried about concerns of human safety and damage to property. They're not going to want to take updates to the software except with a certain amount of control. So they're the ones that need to be kind of involved in that set of trade-offs and the re-architecture. And they're the ones that are going to be pushing, if you're a developer, pushing you to help them get that project up and running, because they won't really understand the intricacies of it. As a developer, what we really want is we want to write code, and we want that code to work, and we want to not be anxious that we might accidentally break something. And that's where the tools of continuous integration and continuous delivery, automated testing, ability to roll back, all these things are very important to making sure that as a developer, I can write code, I can push it, and I don't have to fear breaking things. Much like how a developer on a cloud application doesn't fear taking down their company's homepage when they push code. They have no fear because they have tests and infrastructure and canaries and other kinds of tools that help them stop that. What we're seeing in the tool space, and we consider ourselves part of the tool space too, but what we see in the various IoT tools that are appearing is that they're trying to build on technologies that are really changing cloud and traditional development. So we see that Docker is being used in this, Linux and other technologies, which is making the on-ramp to building IoT projects much simpler and really not as daunting as it was even 12 to 18 months ago. And really another key part of this is the cloud providers. And what we see with cloud is that they're all the big cloud providers are getting into the IoT space in various ways. And it's everything from how they collect the data from the things to how they manage devices, and also how they push the updates to those things. And you have to actually coordinate your IoT pushes, not just the devices, but also to your device management and to your cloud services behind the scenes as you're pushing an app. A simple diagram of DevOps flow, and this is kind of taking something you may be familiar with for cloud and adding in the IoT piece to it. So we've got on the left-hand side, we've got some different developers. They're all working together. They're all happy. They're pushing their code into Git. The Git repository then gets picked up by Jenkins or whatever CI system you happen to be using, and we get a build, test, deliver it, promote it when the quality reaches the level we want. And all these people are collaborating together. The binaries can then get pushed into Artifactory, which is our artifact management system, and it can be scanned by X-ray for security vulnerabilities and for other types of sort of binary trust issues. We have Bintray, which is our CDN for distributing binaries, and then that can flow from that system to your cloud, your device manager, and your the actual devices themselves. And you have to be able to get the binaries all the way out to the edge where those devices actually exist. And so this is where sort of the CDN component comes into play. And what you might notice here is that you probably have different technologies being used, maybe different languages and libraries for the different components here, and you have to coordinate that release. So it doesn't really make sense to think of the IoT release process as separate from your cloud release process. You want to line it all up to flow together, so your developers can work together, can test together, and can release together. Just some use cases that we're seeing in IoT. It's actually kind of amazing, all the different places that we're seeing IoT cropping up. So one example, in manufacturing, we see that there's actually a lot of devices that you may not even think of as devices. You have all the different robots that are doing the assembly. You have the assembly lines themselves, various quality control systems, inventory management, supply chain management, all collecting data and being updated to suit the needs of modern manufacturing that is changing with things like 3D printing and other kinds of manufacturing, and even just-in-time manufacturing, where the demand might be coming from a website order directly to the shop floor. In energy, we're seeing the smart energy is already quite prolific. The ability for an energy project to be able to use data, environmental data and sensors on the ground to tie together demand and supply. It's like a really interesting use case. And there's also just a lot of different tech being built that needs the data collection and needs to have updates. For transportation, there are literally millions of things going around the world, whether that's our supplies, shipping containers and goods that are being transported, to, in the future, we'll see more and more autonomous vehicles and trucks doing deliveries at all the ports and everything. And so how we get from A to B is a really interesting part of the IoT world. And it, again, may not even be what you'd consider traditional, or what you may not consider as IoT. This is just sensors and GPS and these other kinds of systems that are working together to build transportation. And retail, I find to be a very interesting use case. Retail has been a very physical process for a long time. And we've seen over the last couple decades that retail has moved into the cloud, and it's become really an online experience. And it's gotten much more sophisticated as a result of that, with targeting and discounts and recommendations and all these sort of data-oriented retail experiences. And what we're seeing now is that all those retail technologies are moving back into the store. And so you're seeing targeting and recommendations and pricing and discounts and everything happening inside the store, with signage and inventory control and other kinds of techniques to make sure that the retail experience is great online and offline. And this is just a few of the possible use cases for IoT, and I hope that everyone who's listening to this is thinking about their business and what kinds of projects or physical touches you have with your customers that you could turn into an IoT experience powered by software and cloud services. So I showed you this Venn diagram of all the computing you need to worry about, but actually this diagram is incomplete, I should say, because it really is a static image. This shows you the cloud and things as if they kind of exist just at a moment in time. But there's actually a couple missing pieces to this. The first, I would say, is the data intelligence. One of the critical parts of having things in cloud is that they can interact through the data. Things have the ability to collect a massive amount of data from the physical world. They can't do much with that data. And the cloud, it's kind of in a box. It can't really interact with the universe, but it can get that data from things, and it can process data like nobody else. And whether that's using big data, machine learning, or artificial intelligence, being able to quickly understand and make sense of the world via the data coming from things is a critical part of making this system move forward. And of course, DevOps, which is, for me, and the definition I use is just it's using software to build more software. And that's absolutely critical to keeping this whole universe of cloud and things and data moving forward and constantly advancing as you have new ideas for features and new solutions to your customers' needs. So anyway, I wanted to thank everybody very much. I hope this was at least thought-provoking for those of you who are here.
Thank you so much, Kit, for the presentation. And thank you all for joining us today. For the full keynote, you can visit jfrog.com. The whole keynote from SwampUp will be available. as well as a recording of this webinar. It will be sent out in a couple days. And if you are interested in what Kit has talked about, Artifactory, X-Ray, BinTray, and some of our other products, please visit our website and you can download a trial directly from there. Thank you so much, and we hope you have a great day.